This video relates directly to some of the things we have to do in the assignment. First, we look at how we compute rigid body modes of a structure. So rigid body velocity or small displacement, we use velocity and small displacement kind of interchangeably. So if a rigid body has a translational velocity v, then every point on the rigid body has a translation velocity v. If it has an angular velocity omega about a point O, then a point r on the rigid body has a velocity equal to omega cross r, or another point whose position is r1 has a velocity omega cross r1. So the rigid body modes of a structure are translation in the x direction, that means all the points have velocity 1, 0, 0. Translation in the y direction, they all have velocity 0, 1, 0, and so on. And angular velocity about x, so angular velocity of 1, 0, 0, angular velocity of 0, 1, 0, and so on. So let's say we've constructed the 6 rigid body modes of a structure, and we look at the space spanned by these 6 vectors. I'm drawing it like a plane. Of course, this is a 6-dimensional vector space, and it can't be drawn on a piece of paper, but just for visualization, we think of the space of rigid body modes, the span. And now let's say B is an element of the null space of the B matrix. So it could be a combination of internal mechanisms and rigid body modes. If we orthogonally project that B onto the space of rigid body modes, then the difference gives us what the internal mechanism is. This is an idea we'll use in the assignment to separate internal mechanism from rigid body modes.